In this Grasshopper tutorial, we want to model a parametric louver. So you can see that I can change the number of the louvers here on the surface. I can change the degree I want. So I can just change the degrees here. And I can also change the distribution. So you can see that I can change the location, and also we can combine different graphs to produce different results, as you can see here. So this technique is just a simple example of how you can use the twist to produce a parametric louver in Grasshopper. Okay, before we start from scratch, if you're new to our channel, consider subscribing. I will also put a playlist up here, check it out. It's about what is Grasshopper and why you should learn it. And then you can also watch the beginners tutorial, which will help you get started with Grasshopper. And also for this parametric louver, which we are talking, and we're going to explain this now, we have complete advanced lessons, which I will put up here if you want to check it out. For those who want to enroll in our course, you can learn more about this technique in a free-form surface if you want to use point attractors, image attractors. So you can also watch the demo to understand what's happening in the course. So let's get started from scratch and make this parametric louver in Grasshopper. And I'm going to just simply use a surface, a rectangle surface, in this example vertical, so I can explain how fast you can produce a parametric louver in Grasshopper with just twisting a series of surfaces. So what I want to do is to go to the Params menu and pick up this surface, which I just produced as a vertical surface. And I'm going to also put the bifocals plugin so you can see what I'm doing. So the technique is not really hard. What I want to do is to divide this surface first into two sections, okay? Assume that we have this part and this part here. I'm going to divide this first part and use this twisting technique to simply just twist this from here to here, maybe, okay? So maybe it's going to be something like this, okay? And then I'm going to just exactly do as the opposite in the mirror section right there. So this is not really hard. You can easily do that and produce the results. So let's just go and use the surface utility and the Isotrim tool. So I'm going to use this Isotrim. I'm going to give the surface, and because we want to divide the surface into a complete series of strips, I'm going to use the divide domain 2. We have used this in different tutorials, and you can simply just give this to the surface. So this is really easy. The surface goes to the isotrim surface because we want to divide this surface. The domain 2, which basically is what is the domain 2 of the division, is just done by divide domain 2. We can say how many division we have in the U direction and how many in the V count. So we can just simply say 1 in one of those direction and give this a V count in another direction. So you can see how easy it is to control this. You can also change your surface by simply just changing the scale of this if you want to change the results. So let's get back to the Grasshopper tutorial. What we want to do is to twist these isotrim sections or strips. So I'm going to go to the transform. In the morph section, we have this twist thing. If you're in Rhino 5, Rhino 5 doesn't have a twist. You have to install a plugin called Jackalope, I think, if you don't have Rhino 6. And you can find this plugin in foodforrhino.com. So for those who don't have Rhino 6, you can go to foodforrhino.com, find the Jackalope plugin and add it here so you can have twist. So in Rhino 6, we have this native in the Grasshopper components. We want to twist these surfaces. The axis of this surface or twisting thing is really important. So what we want to do is to produce something like this. Let me show you. This is basically the axis of this strip. So you can do different things. You can connect the center of this edge to this edge as a line and twist that. You can use evaluate surface to extract a point in those things. But the best way and the easiest way I think you can do that is to go to the curve, go to the spline and isocurve tool. And that is because you can extract this isocurve as the axis. I'm going to show you just in a minute, so you can give the surface to here. And remember, you have to reparameterize the surface because we want to have a surface from 0 to 1 and 0 to 1. Again, if you don't know about reparameterize, I'm going to put a tutorial up here which we have talked about evaluate surface and why we reparameterize these things. So if I give an MD slider, which will always be combined with a isocurve or a evaluate surface, you can see that we can produce any UV curve on this surface. So if we want to have it exactly at the center, you can see in this curve here, if I move the MD slider, this is going to move up and down. So I'm going to just give an MD slider, but don't change it because 0.5 and 0.5 is fine and it's the center. Now what we want to do is to use this U curve. We don't need the V curve because the V curve is basically this line, which we don't want to twist it around this axis. We want to use this axis. So remember, one of the ways you can use this is isocurve. Another way is to go to the surface, use the construct brep, and explode the surfaces or strips. Let me just turn this off into faces, and then by list item you can pick up the edges. The first edge is here, the second, which is here. It's something like this: first, second, third, and last. So I'm going to just zoom in and give out these edges, and then you can use a curve, a point on curve, which will give you the center of these edges. Let's just give this to the last edge, and then connect that with a line. So remember, you can use this technique if you want to use a line, or you can just simply use an isocurve. I wanted to explain how you can use also an isocurve in Grasshopper to extract a UV curve. So you can also use that if you want to just go more with those components, or simply just use an isocurve and extract the U curve, and don't just change this. So now if I give this to the axis, the problem here, and you can see that it doesn't show you the results, is that this axis is in groups. You can see it here. If you don't see these dashes, you have to go to the display and activate the draw fancy wires. This is in groups, and this input, you can see it's not in groups. So it has 13 strips without groups, and then we have 13 axes with groups. So you either graph this input so it's going to go in groups, or flatten this input so this will also be into just one group. So if you don't know about flatten or graph, like always, you can find a tutorial up here which is related to flatten and graph. So I want to just flatten this. So all of those 13 strips are going to go with these 13 axes. Just turn this off. And now you can see that we can produce that twist. Okay, the next thing is the angle. So I want to just rotate these. I'm going to just say degrees because we want to work with degrees. You can see that if I don't right click and give this the degrees, it's going to rotate that too much because this is in radians. Remember, you can always just right click and put that into degrees, so you can see that this is going to give you the distribution. Okay, so for now, what I want to do is to simply just give a mirror here, and we want to produce a point, a plane just right here, which is YZ direction, and it has to be at the end of the surface. So I'm going to give this a YZ direction, and then we have to just put the origin of this plane at the end of this plane. So I'm going to go to the surface, deconstruct brep, go with one of these vertices, list item, as we always use to extract these things. So this is the first vertex, second, third, and last. So perhaps we have to use the second one. Give this to the origin. Now we can just turn this off. And you can see that how easy it is to produce that. Let's just change the surface. produce the results. So this was one of the ways you can just simply make a twist around this one. But another way you can use this is with graphs. So as I showed you before with this example file, you saw that we use this rotating thing with a range, and you can see that it's just starting with a closed louver and opens up, and then it just goes closed. So I'm going to explain this now. The problem with this simple number is that it's going to twist all of them just a single number. So now what we want to do is we had 14 different strips here. I'm going to use a range, and if you don't know about range and graph mapper, I'm going to put up a great tutorial. We explain this, something similar to this, but it's going to help you understand more about range and graph mapper and those things. I'm going to put it up here, so be sure to check it out if you don't know what's happening here. So if we have 14 different strips, I'm going to connect this 14 to the range, and because when you divide the domain into 14 steps, it's going to give 15 different numbers. So I'm going to just go here and type in the expression x minus 1, and that means that I exactly want 14 numbers. Okay, the domain of the range is 0 to 1, and that is because we want to use a graph, because it always combines well with the graph, which is between 0 and 1, and we can say we want a sine wave. You can double click this and make this a little bit bigger and put that exactly at the center. And now it has a distribution from 0 to 1, but with a sine wave. So if I just give this to the degree, it's not really, you can't see it here because it's just 1 degree. So what we need at the end is to multiply that. So we're going to go to the math, multiplication, and I'm going to multiply that because it's between 0 and 1. I want 90 degrees. So it's going to be between 0 and 90 degrees. So I'm going to give this to the angle. You can see it's going to start from 0, open up to 90 degrees, and then close to 0. That's it. So you can see how easy it is. We can control that. We can control with the sine wave. And the best thing you can do is to combine graphs. I'm going to give this a Bezier distribution. You can see how easy it is to produce this section. Okay, now we can simply just go to the surface and into the brep join and join this set of twists with this with the shift key, and then we can have 14 complete strips here. You can also just type an offset surface to make this a little bit thick and give this a distance for the thickness and the solid to yes. Okay, let's just check this out for 3. That's fine. You can see that it's going to produce something like a solid, and let's just go to the rendered mode so you can see it. So that was the tutorial of how you can produce a twist. If you want to know more about this, we have about 1 hour of lessons in the course, so you can also check that out. And thanks for watching. See you next time.